we have to find the equation in standard form. The way you do that is by completing the square on x and y. Here we have 4x squared. It should be together with the other x term. We also want the y squared term together with the first power y term. And the constant will need to go to the other side. So you can rearrange it. You can put the 4x squared with the negative 16x, followed by negative 9y squared, plus 54y. To move the constant to the other side, we'll go ahead and add it to both sides. This way it's on the other side. Now this is a case where we have to go ahead and factor out GCFs from both the x terms and the y terms. So here there's a GCF. You basically look at what's the coefficient of the squared term. If this is 4x squared, you take out the 4. And when you factor out a 4 from 4x squared, all that's left is x squared. When you take it out of the 16, all that's left is minus 4x. Now, this has a negative sign with the 9, so you also have to factor out the negative sign. And when you do that, and you take out negative 9 as the GCF, this will just be y squared. This is the same as 54 divided by negative 9. So this would end up being negative 6. The sign will flip, but the y term will stay there. And nothing happened with the constant. It'll still be the same. We're going to set up the plus blanks inside the parentheses. So we'll make a space here after the first power x term, and we'll put a plus blank. And we'll do the same thing for the red parentheses, where we have the y terms. We'll go ahead and put a plus blank on the inside. On the other side, we still have the constant, but it's an equation. So since we introduced this plus blank here inside of the parentheses, which is being multiplied by a 4, we have to do that to the other side as well. We have to put a plus blank, it'll be inside parentheses, and there will be a 4 on the outside. And then the same thing happens with the y term. This one, you'll put the negative 9 on the outside of the parentheses. Inside, you'll have the blank. And now we have to find out what the term is that goes in the blank. This is the c term. That's different from the c value. The c term is for that third term inside, for the trinomial for both of these. C equals b divided by 2, and you square that. Inside the parentheses, the first one is a, the second one is b, and c is this third one that we're trying to find. So b for this one is negative 4. That means you take the negative 4, divided by 2, put it inside the parentheses, and square this. It turns into negative 2 squared. That means that this is 4. The 4 has to go into this blank and into that blank at the same time. And now you do the same thing for the y parentheses. Here there's an a, this is a 1. B is negative 6, and C is what we're trying to find. But since we know that B is negative 6, you take the negative 6, divided by 2, close the parentheses and square this. This will now be negative 3 squared, which means that this is 9. This blank and this blank are both 9. What you want to do now is factor the left side and simplify the right side. On the right side, we have 101. This is the same as 16, and this is 81. If you add the 101 with the 16, that's 117. And then if you subtract 81 from that, you got 36. On the left side, we'll leave the 4 on the outside. I'll show 2 different ways to do it. One way is where you have the 4 on the outside, but you set up 2 parentheses. And to figure out what goes in the parentheses, you're looking at the x squared. You got x squared from x times x. You put one x here and the other x there. Then you look at the b term, which is the negative 4. You keep the sign with it, divided by 2, and this is negative 2. It goes into both of the parentheses. You have x minus 2 twice. The way you'd indicate that is saying that it's squared, and you leave the 4 on the outside. Another way to do it is by leaving the GCF on the outside again, but it's with the understanding that it's going to end up with a parentheses squared. And so you take the square root of y squared, or you can do it the same way. You can think about it as y times y. Either way, you'll end up with 1y in this parentheses. And then you do the same thing. You look for the b term here. This is -6. So you say -6 divided by 2. This is -3. And that goes inside this parentheses. Now I'm going to rewrite the main parts. Here we have this from the x side. Here we have this from the y side. And this is from the constant. The last thing you have to do to find the equation in standard form is to turn this side into a 1. Whatever number there is here that isn't 1, just take that number and divide everything by it. On the right side, this is now 1. On the left side, 4/36 as a fraction, that's 1/9. And so if I do it on the side, you have 4/36 times the x minus 2 squared. The fraction simplifies to 1/9. And then you can just put the 1 and the x minus 2 squared together, multiply them together, and just put it on top of the fraction. So that's how you would get this side. On the right side, you're doing the same thing. You're thinking about -9/36 times the parentheses. The fraction reduces, it's -1/4. And then you can just put this on the top. You can also, we'll leave the sign out front, but you can put the parentheses on the top by multiplying it with the 1. It would be -y minus 3 squared over the 4. And so the subtraction sign is already there, and we'll just say y minus 3 squared over 4. So this is one way you can confirm. If you notice, the 4 has gone down there, and the 9 has gone down there, almost as if they switch places. It's just how it works out with this question. But now we have the standard form of the equation, so that takes care of the first part. Next, we have to find the center. To find the center, there's a very fast way you can do this. We need to know what h and k are. Now, the one we have here, it's based off of this, where you have x minus h squared. So we'll have the x minus h squared, and we'll have the y minus k squared. And on this side, there will be a 1. Just going back, we started off with the 4x squared minus a 9y squared. So we have two squared terms from two different variables, x squared and y squared, but the subtraction sign between them is what tells you that it's a hyperbola. That's the big clue, where you have x squared, y squared, and a subtraction sign. One of them is negative. So because of that, we know it's a hyperbola. The positive one is a squared. So if you look at it like this, where either you can think about it over here, we had the 1/9, that was positive, whereas the -1/4 was negative. Or just looking at the equation itself, this one is positive, whereas the y term is negative. So the positive one is a squared. A squared is under the x term, and b squared is under the y term. We're just trying to find out what the center is. So we know what the form of the equation is that it's based off of. And just looking at where h and k are, h is with the x in parentheses. But when you take it out from this parentheses to put it over here, you flip the sign. And same thing for k. K is with y, but the same thing is that when you take it out of this parentheses to put it over here, you flip the sign. This means that the center is actually positive 2 for h, and it's positive 3 for k. So this is the center of the hyperbola.
Okay. Got it.
Alright, excellent. So that takes care of the second one. Now we have to find out the transverse axis. To find out what the transverse axis is, you want to look at the form of the equation and the center. So here, this is the kind where a squared is underneath the x term. That means that it's going sideways. The x-axis will be important. The center isn't on the x-axis itself, it's just off of it. So for the transverse axis, you would say that it's parallel to the x-axis. The x term is the positive term, which at the same time means that the a squared term is underneath the x term. That will tell you that the x-axis is the important one here. And then because the center isn't on the x-axis itself, to have been on the x-axis, it could have been, for example, 2, 0 instead of 2, 3. But since it's not on the x-axis itself, then that's why it's parallel to it. And just to kind of sketch it, the center is over here. So what we're looking at will be going sideways because this is based off the x-axis. That's why it's parallel to it. It's not on the axis. But if it was instead 2, 0 for the center, and we knew that this was one where the x squared term was positive, or that a squared is underneath the x term, then the hyperbola would be more something like this, and it would be on the x-axis. So that's how you know that it's going to be parallel to the x-axis, and that completes that part. The last thing is to find out what the ABC values are. So it didn't ask for the foci or anything this time, did it?
No, just ABC values. That's it.
So we're trying to find out what the A, B, and C values are. First, we have a squared. A squared is the 9. It lines up exactly. And b squared is the 4. So you can make a list here off to the side. A squared is 9. B squared is 4. So you have the square root of a squared and plus or minus the square root of 9. Here the radical and the exponent cancel out, so it would just be a. And then on this side you have plus or minus 3. So now we know what a is. And then here you do the same thing for b squared. And you get b is plus or minus 2. To find out what c squared is, it's a squared plus b squared. That equals c squared. We have 9 for a squared. We have 4 for b squared. That equals c squared. And so this would be 13 equals c squared. You can switch these around. You could have started with the c squared on the left side. But at some point you'll get here, where you have the square root of c squared equals plus or minus the square root of 13. And so the radical and the exponent cancel out. But here we can't reduce this without using decimals, but we want to get the exact form of it, so you keep it as a radical. And this is how you can find out what the c value is. And so we found the a, b, and c values as well.